If you've got the DJI FPV system, then you know that the DJI Air unit needs to be connected to your flight controller. These gray and white wires need to go to a UART, TX, and RX on your flight controller, and one of the things that does is give you a working on-screen display. But more importantly, it lets the Air unit know when you have armed and disarmed the quad. And that's about more than just convenience. Yes, the DJI goggles can automatically start and stop recording when you arm and disarm the quad. But more than that, it's used to keep the Air unit from overheating. These digital video transmitters make a ton of heat, and so when your flight controller is disarmed, they go to a low power mode and they stay a little bit cooler. As soon as you arm, they go to full power mode, and then the air from your quadcopter keeps it from overheating. But there's a problem. What if you have a vehicle that doesn't have a flight controller? Like, for example, you've put a DJI Air unit on a car. One option is to go into your goggles settings and turn off the low power state of the Air unit. That's what it looks like for the DJI O3. For the O4, the option has a different name, but basically all the DJI Air units have the ability to cause them to go into low power mode when you're not armed, in order to keep them from overheating. And you can turn that option off for the Vista and the O3, and then they will go to full power and full performance, although they will overheat much faster, so you kind of like that option to work. With the O4 Air unit, although it will go to full power if you turn temperature protection off, it still doesn't go to like full performance, like the frame rate still isn't right, like the processing is still bottlenecked. And so with the O4 Air unit, you actually can't really disable this option entirely except by connecting the Air unit to a flight controller so it knows when you're armed. That's the ideal situation. Well, one option is to buy this or something like it, the Chad Rains FPV-04 Armor. And this is a little device that plugs into your Air unit, it plugs into your receiver, it detects when you have armed the drone, and then it tells the Air unit, hey, we're armed, go to full power. But that costs $52. Wouldn't it be nice if there were something you already had on your vehicle that could perform this function and didn't cost you any extra money and just do it automatically? Guess what? It's your ExpressLRS receiver. The ExpressLRS devs have made it so that the ExpressLRS receiver can tell the DJI Air unit when you're armed and disarmed. I'm Joshua Bardwell, and you're going to learn something today. We're going to do it. The first thing you need to know is that in order to take advantage of this feature, you must be on ExpressLRS 4.0.0. That's when this feature was added. Where is it in the release notes? There you go. New DJI output protocol. Slap that DJI Air unit out of low power mode without needing a flight controller. Most likely, if you're doing this, you're going to be doing this with a PWM receiver, because if you have a serial receiver, then most likely it's being used with a flight controller, and then the flight controller can just tell the Air unit when it's armed and disarmed. But if you have a PWM receiver, in other words, a receiver with just servo plugs, then it's more likely that you have a vehicle that doesn't have a flight controller and it's just running servos straight off the receiver. The way this feature works is that you're going to take two of the PWM outputs, two of the servo plugs on your receiver, and you're going to turn them into a TX and RX. They're going to turn them into a UART that's used to talk to the Air unit. So if you have a receiver like this ER5CI, which only has 5 outputs, if you're using all 5 of those outputs, or even 4 of those outputs, you're not going to be able to do this. You need 2 spare outputs to connect to the DJI unit for the TX and RX pins. I do want to point out that some non-PWM receivers, some serial receivers, have an extra UART. Look right here, TX2 and RX2. This is on the XR4 receiver. The first UART is the default TX and RX pads that every receiver has, and then there's an extra one here, TX and RX, a second UART. We could theoretically put a DJI Air unit on that if we wanted to, but again, probably we've got a flight controller if we're using this receiver. I guess I should say that you could just take a normal ExpressLRS receiver and connect the TX and RX pins to a DJI Air unit, and it would arm and disarm the Air unit, but it wouldn't be usable as a receiver, so I'm not really sure what the benefit of that would be. But we're going to do this example with a PWM receiver. This is the ER3CI, and it's kind of silly to do this with a 3-channel receiver because I'm using 2 of them for the Air unit. That leaves 1 of them for nothing. This is just a demonstration. The point being that it's just a demonstration. You can do this with any number of PWM channels. You just need to know how to set it up. How do you set it up? Well, the first thing I'm going to do is I'm going to go to my ExpressLRS Lua script, and I'm going to put the receiver into Wi-Fi mode because enable RX Wi-Fi. There we go. Receiver will go into Wi-Fi mode. And then here on my computer, I will look for ExpressLRS RX. I'm going to connect to that. The password is ExpressLRS, all lowercase. And then I'm going to go to 10.0.0.1 in my web browser. Sometimes that page automatically opens, especially on some mobile devices, but oftentimes it doesn't. You need to manually type it in, and here we are. Again, you need to be on ExpressLRS 4.0. If you don't know how to flash to ExpressLRS 4.0, I'll put a link in the video description below to a tutorial. And again, keep in mind that ExpressLRS 4.0 is not backwards compatible with ExpressLRS 3.x. So if you update one of your devices, you're kind of committing to updating all of them, or I guess maintaining a second radio with ExpressLRS 3.x on it for your vehicles you haven't updated yet. Once we're in the web page, we're going to go to connections, and this is where we can remap these pins. This is my 3 PWM outputs, my 3 sets of servo pins. If it's set to 50 Hertz, that's a servo output, and if it's set to serial, well, I've already done this, so what you should see is that they're all set to 50 Hertz, and what you're going to do is you're going to go through and you're going to look for one that has serial TX or serial RX as an option. If we look at pin number 1, do you see that that's not an option? Let me scroll, just make sure nothing's, yeah. Do you see that serial TX is not an option? You can't put serial TX and RX on any pin. And so you might have to do some shuffling of your servo plugs if you've got something on pin 2 or pin 3. But here we see that pin 2, I have the option for serial TX, and that makes pin 3 serial RX. You're going to write that down or remember it because you're going to need to know that in a future step. If you do end up needing to shuffle some pins around, like you've got something on channel 2 and you need to move it to pin 4 or pin 5 because you've turned pin 2 into serial TX, you can remap that here. This input here lets you put any input channel on any output pin. So like theoretically, you could take pin 3 and make it into channel 2. So if you do need to move a plug, you don't need to just reshuffle everything in your whole your aircraft or your whole receiver, your whole mixer, your whole controller. You don't just need to reshuffle everything. Okay, so we've got serial TX on 2 and serial RX on 3, and you're going to hit save. And then you're going to go to serial, and this is going to control what protocol comes out that TX and RX pin. And you want to set that to DisplayPort. That is the one that makes your DJI work correctly with the receiver. And you're going to save that. Once you've done that, the next thing you need to do is wire up the air unit to the receiver. And a lot of this stuff you don't need to worry about. Like this is a 5-volt regulator. That's just for this demonstration. You're probably getting power for your receiver from like your BEC, your ESC or something on your car or whatever. So you won't have that. And then here is power going to the air unit, and you've got that wired up to a battery or something. Obviously, that's not really specific to this example. What is specific to this example are the white and gray wires. The white wire is going to go to the TX on the receiver, and the gray wire is going to go to the RX. So for me, TX was 2 and RX was 3. And you can see right here that I have just spliced a servo plug onto the wire and soldered it to the gray and the white wire, and then I have plugged it into the receiver so that that goes to the signal wire, or the signal pin, and I've got the white wire going to channel 2 and the gray wire going to channel 3, the TX and the RX. That's it! That's literally all you have to do. This is relatively simple compared to some things that you do in the world. It could be more complicated. So right now you can see it says air unit in low power state, and you can see we are at 7 megabits per second. That is all indicating that we are not at full power. If I then flip the arm switch, here we go. Oh, I'll show this camera. Here we go. We're going to flip the arm switch. Ready? Armed. And it begins recording. Well, it tries to begin recording. There's no SD card in the goggles, so it can't. It begins recording. It goes to full power, 50 megabits per second. And here we go. It is now armed. And if I disarm, it stops recording, and it goes back down to 7 megabits per second. That's it. It's working. We're automatically arming and disarming when we flip the arm switch. And this is going to work with any DJI Air unit. It'll work with a Walksnail Air unit if you want. It'll work with any digital air unit that understands that MSP protocol. You know, there is something that I kind of thought it was going to do that it turns out that it doesn't do, which is that the analog receiver has a battery voltage sensing wire, and I've hooked it up. So the receiver knows the battery voltage, even though there's no flight controller to get telemetry from. And I kind of thought that the receiver would then pass that voltage to the goggles, so the battery voltage would appear in the goggles, but it looks like it isn't doing that. I actually passed that idea to one of the ExpressLRS devs, and he was like, oh, interesting. So it's possible that that will be implemented at some point in the future, but for the time being, it doesn't. If this feature saved you $50 because you didn't have to buy the Chad Rains arming device, sorry, Chad Rains, to take money out of your pocket, but if this video did save you money, consider making a donation to the ExpressLRS project. Normally, I would ask you to join my Patreon. I don't like to do that in ExpressLRS videos because the ExpressLRS devs do a lot of work for free and they need support as well. Not for their personal pockets, they don't take a paycheck, but just to support the project because developing software costs money for servers and test equipment and so on. You can do that through the link in the video description below. They have an open collective site. At the moment, the page isn't loading. I don't know why, but hopefully by the time you're seeing this, the page will load. I believe in this so much that I am a monthly subscriber to the ExpressLRS project, and I would encourage you guys to make a one-time or recurring donation. Yeah, for sure. Just, they deserve it. But this is not the only cool thing that ExpressLRS 4.0 can do. ExpressLRS 4.0 has added a whole bunch of really amazing features. Normally, like an upgrade of firmware like this is just like, whatever. But this is definitely worth at least looking at. I'm going to put a card on screen and a link in the video description below, if you can't see the card, to my ExpressLRS 4.0 release overview with all the new features of ExpressLRS. As well, I'm going to put a link to my tutorial about how to connect a GPS receiver to your ExpressLRS receiver so that you can get GPS telemetry and location tracking even on devices that don't have a flight controller at all, like an RC car or boat or an old-fashioned plane that doesn't have a flight controller. It's a pretty cool feature, and I think you're going to want to see it. Cards on screen, links down below. I'll see you there.